Welcome, everyone, and thank you for joining us today. My name is John Francis, and I am the Senior Vice President of Business Development at ETAP. We're excited to present our Advanced Distribution Management System, or ADMS, and show you how it can help to enhance operational efficiency and reliability in your distribution network. Today, we'll cover the following topics: customer challenges, industry available solutions, the ETAP value proposition, along with a product demo of our ADMS solution, and end with tangible key customer benefits. Let's dive in. First, let's discuss some common challenges faced in power grids today. If we take a look at the United States and Europe, much of the US electrical grid was built in the 1960s and 70s, and around half of all the grids in the EU are more than 20 years old. One major challenge is the increasing electricity demand due to the rapid growth of data centers and transportation electrification. This surge in demand puts significant stress on the distribution networks, requiring more robust and reliable solutions to ensure continuous service. Currently, 30% of LCOE, or levelized cost of energy, is related to operation and maintenance costs. This requires the need to provide highly efficient new energy optimizing actions by bridging the gap between planning and operations, with a focus on people and asset safety, system reliability, operational efficiency, and security. Another critical challenge is the integration of renewable energy sources. As more renewable energy sources come online, the variability and distributed nature of these resources present significant challenges for maintaining grid stability and efficiency. Global share of variable renewables could increase to 34% by 2030 and 60% by 2050. Effectively integrating these renewable sources while optimizing for the current demand from large consumers is essential for a reliable distribution network. However, there are current limitations of other solutions. As we assess the current ADMS landscape, it's clear that many systems suffer from critical integration challenges, from disjointed design to operation workflows to fragmented model management. These systems are very rudimentary, providing a SCADA, yes, with nice dashboards, but no real meaning. It may provide a high-level voltage optimization approach, but it lacks a connection to planning, and an outage management system that does not include an intelligent or accurate method to detect, isolate, and manage faults. The lack of a cohesive SCADA, network planning, protection, distribution management and optimization workflow, coupled with the absence of microgrid digital twins, which usually requires a completely different product or solution set that has no knowledge of the rest of the distribution system, leaves operations vulnerable and limits the ability to fully optimize distributed resources. Furthermore, there's the inadequate ability to simplify determining regulation compliance, no methods for working in a collaborative environment, and the inability to provide real-world training scenarios for a workforce currently experiencing a shortage in skilled resources. This exacerbates these issues, underscoring the need for a unified, forward-looking solution that can drive both operational resilience and strategic growth. ETAP stands apart by offering a truly integrated model-based solution that directly addresses the critical gaps in other ADMS platforms. We deliver a seamless flow from design to operation, ensuring that models are not only maintained, but also fully integrated across all aspects of operational planning. With ETAP, you gain a unified system that brings together protection, planning, operations, optimization, including safety and compliance regulations, all under one comprehensive platform and digital twin model. This includes details within the feeder network, substations, and connected microgrids to provide the ability for engineers to perform system studies using operational data and for the operators to manage and optimize the system using system design knowledge. Our approach ensures that the entire network is accurately represented, managed, and optimized. We also provide robust support for system interoperability with the IT and OT network, real-world training scenarios to uplift new staff, and situational awareness, empowering your organization to proactively manage operations with greater reliability and foresight. In short, ETAP equips your operations with the advanced capabilities needed to overcome the limitations of traditional systems, driving both efficiency and strategic growth. Let's take a look into the different applications within ETAP. In this project, we have 115 kV, with transformers bringing it down to 34.5 kV into our distribution substation layer. We have modeled 2 substations, where power is further stepped down to 11 kV for our distribution network. We have 3 feeders, 1 de-energized and 2 energized, feeding into the distribution network. For the other substation, it's simpler, with just 2 feeders feeding into the network. Now let's move to our distribution view. Here, you can see our primary distribution network. Everything in blue represents the distribution network. Zooming in, you'll see our 2 substations with feeders extending. We've also modeled our secondary distribution network, including the distribution transformers and end customers, such as commercial and residential buildings. Let's take a look at our feeder diagram. By right-clicking on a feeder breaker, we can dynamically create a feeder view. This orthogonal view provides a schematic feeder representation of the network. Various configurations, such as top-to-bottom or bottom-to-top views, can be set in the rulebook, offering flexibility in how you visualize your network. Another important visualization is NetView. This view simplifies the network by stripping out unnecessary information, focusing on lines, protective devices, and status interconnections. It provides a powerful automatic way to visualize outages and network interconnectivity. Now, let's dive into the real-time portion. Here, I have my actual meter data and virtual metering calculations, showing real-time flows throughout the distribution network. Virtual metering significantly enhances grid management by providing operators with accurate, real-time insights into the electrical state of the system without relying solely on physical meters. Virtual metering is possible by leveraging the digital twin with advanced algorithms to estimate power flow, voltage levels, and load conditions across the grid, filling in data gaps, improving visibility into an otherwise unmonitored area. As a result, operators can make more informed decisions, optimize grid performance, and quickly respond to anomalies, leading to a more efficient, resilient, and reliable power system. Load allocation is also included, and this is crucial for understanding real-time flows and losses across the distribution network. We calculate losses, both due to heat and unaccounted for losses, which can indicate issues like theft. This data feeds into various study modules like unbalanced load flow, time domain load flow, enabling predictive simulations. You can perform what-if scenarios such as transferring loads between feeders to assess potential overloads. Other analysis that can be performed within the same software using the single source of truth digital twin include short circuit, protection and coordination, arc flash for safety compliance, and power quality assessment. With the ETAP model, we can automatically create an HMI for operators. This model is used for analysis and planning and be pushed out and viewed in our HMI viewer. eWeb is our web-based user interface, offering the same HMIs, but accessible via a browser on any device. eWeb requires no installation, providing mobile-friendly views that adjust to various form factors. We've significantly expanded eWeb to include advanced visualizations, such as substation panel views with real-time data and network views showing all interconnections. With the intelligence of the digital twin driving the graphics, the distribution network and substation visuals are automatically updated based on the status and operations of each device. This is without the typical manual manipulation of antiquated ADMS systems. The load allocation data feeds into our predictive simulation, allowing for continuous monitoring and analysis of the distribution system's performance. Predictive simulation is crucial for bridging the gap between planning and operations because it provides a dynamic and forward-looking approach to managing distribution systems. Predictive simulation allows operators and planners to visualize, analyze potential future scenarios before they happen. By simulating various operational conditions, including extreme events, it becomes possible to test and refine plans in a risk-free environment. This foresight enables better informed decisions that align with both current operations and long-term strategic goals. Situational intelligence is enhanced through predictive simulation, periodically calculating potential issues before they arise and alerting you through a user-friendly interface. Traditional planning methods often rely on historical data, which can be limiting in the face of rapid changes in technology, demand, or environmental conditions. Situational intelligence, on the other hand, leverages real-time data and advanced modeling techniques to anticipate issues before they occur. This proactive approach helps in identifying potential bottlenecks, failures, or inefficiencies early, allowing for timely interventions that can prevent costly disruptions. There is often a disconnect between planning and real-time operations due to differing time horizons and objectives. Predictive simulation and situational awareness acts as a bridge by integrating planning models with operational data. This ensures that operational decisions are made with a clear understanding of a long-term plan, and vice versa, that planning accounts for real-world operational constraints and variability. Volt-var optimization is one of the key objectives of distribution management. By optimizing the voltage and reactive power in our distribution networks, VVO allows us to maintain optimal voltage levels across the grid while minimizing power losses. By reducing voltage levels with regulatory limits using CVR, VVO helps in lowering energy consumption without compromising service quality. This directly translates into cost savings for both the utility and the end customers. We can dynamically manage reactive power, ensuring that the grid remains stable, even under varying load conditions. This is especially crucial as we integrate more renewables, which can introduce volatility. VVO can be assessed using result analyzers as well as AI, leveraging ETAP's Electric Copilot. Using common language search, VVO results are quickly assessed and documented. Switching sequence management allows you to create, validate, and switch plans based on real-time data. For example, if you need to take a transformer out of commission, you can create and validate a switch plan to ensure it won't cause any issues. Switching optimization Feeder balancing, loss optimization are critical components in modern grid management that work together to enhance the overall efficiency and reliability of power distribution. Switching optimization allows operators to dynamically reconfigure the grid by selectively opening or closing switches, thereby improving load distribution and minimizing disruptions. Feeder balancing ensures that electrical loads are evenly distributed across all feeders, reducing stress on the infrastructure and preventing overloads. Meanwhile, loss optimization focuses on minimizing energy losses across the grid by optimizing the flow of electricity and reducing inefficiencies in power transmission and distribution. Together, these strategies not only improve operational efficiency, but also contribute to a more stable and sustainable power grid, ultimately reducing operational costs and enhancing service quality for end users. These validated switch plans can be integrated into our switch order management solution, following a full workflow from request to execution, ensuring a seamless maintenance process. Our outage management solution integrates with the switching management to provide a comprehensive approach to handling outages and maintenance requests. When it comes to maintaining grid reliability and customer uptime, ETAP's fault location, isolation, and service restoration, and optimized fault management service restoration go beyond the basics. Our Flizzr solution is designed to do more than just restore power quickly. With optimized FMSR, you have the power to tailor your approach to reliability. By integrating selectable objectives, ETAP ensures that your specific goals, whether it's maximizing uptime, reducing operational costs, or enhancing overall efficiencies, are met. This isn't just about keeping the lights on. It's about doing so in the smartest way possible. ETAP's solution optimizes every aspect of fault management, balancing cost and efficiency with your reliability targets. We offer extensive reporting capabilities, including operation shift reports that automatically generate at the end of each shift, and alarm reason reports that link events like circuit breaker trips to associated faults for detailed analysis. ETAP's Operator Training Simulator is a cutting-edge real-time training solution designed to immerse operators in lifelike scenarios with full system response. Think software in a loop. With OTS, operators can safely experience the full spectrum of grid operations, from normal conditions to extreme emergencies, without the risk of real-world consequences. OTS integrates with ETAP's comprehensive platform, providing operators with access to a wide array of features, including real-time simulation, where you can simulate and interact with your actual system in real time, allowing for a hands-on learning and immediate feedback approach. Scenario-based training is tailored to reflect real-world challenges, helping operators master complex procedures and decision-making skills. With event playback, we can analyze past events with precise playback controls to understand operator responses and identify areas for improvement. Within a multi-user environment, we can collaborate with team members in a shared, synchronized environment to enhance teamwork and communication. As the complexity of modern power grids increases, the role of operators in maintaining grid stability and resilience has never been more critical. ETAP's integrated environment, combined with its advanced microgrid capabilities, empowers operators by bridging these solutions directly into the forefront of ADMS. By integrating microgrid systems into the ADMS, Operators can seamlessly manage both centralized and decentralized resources from a single interface. This unified control enhances situational awareness, enabling operators to make more informed decisions and respond swiftly to grid events. With ETAP's microgrid controller integrated into ADMS, operators can automate complex processes of controlling energy resources and optimize the dispatching of the assets. This level of automation not only reduces operational costs and overhead, but also minimizes human error, leading to improved overall grid efficiency. In the event of grid disturbances, ETAP's integrated microgrid solution allows operators to quickly isolate and stabilize affected areas. This enhances the resilience of the grid, ensuring continuity of service even under challenging conditions. Using historical or forecasted data, we can manage our Scope 2 emissions with a sustainability analysis dashboard to track carbon emission KPIs. This dashboard is used for monitoring current emission outputs and to predict the impact of future energy efficiency initiatives. From within the same solution, you can view emissions compared to goals, the success of your initiatives, and emission output per device or device type. All this without moving to a completely different ESG reporting tool. This concludes our high-level overview of ETAP capabilities. We've touched on everything from network modeling, real-time data integration, to advanced visualizations and outage management. Now, tangible key customer benefits. Let's talk about our cost savings. ETAP optimizes how electricity is distributed across the grid. By ensuring that energy is used more efficiently, customers see a direct reduction in their monthly bills. This isn't just about minor adjustments. It's about meaningful savings that add up over time. ETAP transformed Noida Power's traditional utility to a smart utility, realizing over $21 million in savings over 6 years, including $9 million in savings of asset integrity and reliability. Speaking of reliability, when our advanced grid management capabilities, customers experience fewer outages and a more consistent electricity service. This means less downtime and more confidence that the power will be there when it's needed most. We also play a crucial role in supporting sustainability goals for smart cities. Our system is designed to improve energy efficiency and facilitate the integration of renewable energy sources. This allows customers to reduce their carbon footprint, contributing to a greener and more sustainable future. Cities of the future will soon account for 90% of the world's population growth and 75% of its energy consumption. The pressure on critical resources will increase. The new administrative capital in Egypt launched one of the country's most ambitious development projects to date, setting standards in smart city living using ETAP. ETAP manages, controls, visualizes, and optimizes the power distribution required to run critical smart services for city operators, citizens, workers, and visitors alike. Included with smart cities is proactive problem resolution. Our technology detects potential issues before they become problems for our customers. By addressing these challenges in advance, we ensure that service remains uninterrupted, providing peace of mind and continuous power. Finally, our system helps in extending the lifespan of critical infrastructure. By reducing strain on the grid and optimizing operations, we minimize wear and tear on the equipment that our customers rely on. This leads to fewer disruptions and ensures that the systems in place last longer, reducing the need for costly replacements and maintenance. In summary, our ADMS delivers tangible benefits: lower energy costs, improved reliability, stronger support for sustainability, proactive problem solving, and longer lasting infrastructure. These advantages make a significant difference in the daily lives of our customers and align with our commitment to providing a superior, more sustainable energy experience. Thank you.